Reproducing the stiffness of virtual objects is crucial for enhancing the haptic feedback in virtual environments. Usually, this requires either soft physical objects or force feedback devices. To explore how different stiffness levels can be better reproduced, we focused on the interaction between the user and virtual objects using a stylus. This is an example of using a stylus to touch a soft object in a VR environment. To reproduce different levels of stiffness, the object touched by the stylus must be changed accordingly. Through subject experiments, we confirmed that combining a soft stylus with visual stimuli can create the illusion that the object being touched feels soft. We hypothesized that by developing a stylus-shaped device capable of dynamically altering its stiffness through the use of artificial muscles, it would be possible to dynamically adjust the perceived stiffness of objects touched with the device. We use McKibben artificial muscle mechanism to make the device. The hardware consists of two different types of tubes and its contained fluid. With one end closed, the tube part expands when pressure is applied from the other. On the other hand, the tube part contracts when reducing the pressure. These works cause changing the overall stiffness. This is a prototype device. Rotation of the motor makes piston action. The device attempted to replicate the stiffness of three objects: a sponge ball, soft; a plastic ball, medium stiffness; and a tennis ball, firm, and presented them to the subjects. Consequently, by dynamically changing the stiffness of the device, the subjects could perceive the stiffness corresponding to the material of the virtual object. Here is the result of the evaluation. When the device stiffness is minimal, the perceived stiffness aligns with that of the sponge ball. When the device stiffness was set to half, the perceived stiffness corresponded to that of a plastic ball. When the device stiffness is at its maximum, the perceived stiffness matches that of a tennis ball. We proposed a stylus-shaped interface with a dynamically adjustable stiffness using artificial muscles. The device successfully reproduced the perceived stiffness of virtual objects,